In this video, I will go over a quiz that covered the first 5 days of a probability unit. So we're going to be talking about the very basics of probability, and we'll be working a lot with Venn diagrams and set notation. First, we need to establish the basic sort of notes that you need to be familiar with. So here is the ground level. Throughout this video, you're going to see a symbol that looks like this show up sometimes, and a symbol that looks like this. Now, when you see this symbol, you will interpret it as and. When you see this symbol, it will be or. Now, when you're talking about and, it's always going to be the overlap of two sets. And when you're dealing with an or situation, it will be all of both sets. So in the sense of a Venn diagram, all right, if you have two sets and you're dealing with an and situation, then you're just talking about this part of the Venn diagram right here. But if you have a Venn diagram representing two sets and you're dealing with an or situation, well, then you're going to be looking for all of both sets. So that would be more like this. Okay, now let's say that, let's see, let me change colors a little bit. Let's call this set A and this is set B. All right, same here. This is set A and this is set B. There's a formula for or that goes like this. It's going to be, first of all, here comes the symbol that I mentioned. If I write A or B, okay, that's how you would write that. And the formula is, it's going to be set A plus set B minus the overlap. Now, I just said that the overlap is A and B. So another way that you're going to see this is A or B is going to equal A plus B minus the intersection A and B. All right, but it's really just A plus B minus the overlap. Okay, so those are the basics, so that should be enough to get us started. I may add on more notes as they are necessary. Here's a little bit more that's necessary. This concept of not. All right, so you're going to see things like this. If you see A with a mark on there, that means not A. And another way of writing that is to put a symbol like this. Okay, these are the two most common ways of writing not A. But that is also called a complement. So every once in a blue moon, you might see it written this way, a complement. But anyway, if this is set A right here, all right, and I'm going to put it inside of a rectangular universe. If that is set A, then not A, or a complement, is going to be everything outside of set A. Okay, I'm not going to make this a perfect coloring job because we got a lot to cover. All right, so now let's start doing actual problems. For a group of high school students, define events B F, and S as follows. B is being a boy, F is being a freshman, and S is being a senior. Boy, freshman, senior. Now, which of these represents boys who are not seniors? So, that means to be in this set, you have to be a boy and, at the same time, not a senior. So we're looking for boy and not senior. And that will be option C. Okay, because this symbol means and. So you're both a boy and you're not a senior at the same time. So that would be a boy who is not a senior. Problem number 2. Which of these represents students who are neither boys nor seniors? Okay, this is a little bit tricky. So when they use this word neither, okay, neither is the opposite of or. So this is going to come up a lot. So when you see neither A nor B, okay, that's the same thing as saying not A or B. Okay, think about it. A or B would be anything in either A or B. It's A or B would be all of both. Okay, like this is a picture of A or B. Okay, so not A or B would be like this. All right, if this is A and this is B, not A or B would be everything outside of this. Okay, and just in your common everyday speech, you would say, if we're outside of both of these, then you're neither in A nor in B. You're not in either one. Okay, so neither A nor B is the same thing as not A or B. Okay, so we're looking for students who are neither boys nor seniors. So we're looking for not boys or seniors. And that's what I see right here. Not boys or seniors would be the same thing as neither boys nor seniors. Okay, number 3. Which pair of events are mutually exclusive? Okay, well, back to the notes. Let me scroll down a bit. All right, mutually exclusive versus overlapping is really what we're talking about. Let me see if I can insert a little more space. All right, all of the sets we've been looking at so far were overlapping. Okay, because they have some elements in common. All right, see this overlapping part right here. But mutually exclusive would be like this. All right, 2 sets for which there is no overlap. All right, meaning that it's impossible to be a member of both sets. For example, you cannot be a freshman, right? If this was freshmen and if this was seniors, there's no way you could be a freshman and a senior. There are no freshmen who are also seniors. On the other hand, if this is freshmen and this was boys, you could be a freshman and a boy at the same time. You could be in the overlap. Okay, so which pair of events are mutually exclusive? You could be a boy and a freshman. You could be a boy and not a freshman. So these are overlapping. but there's no way you could be a freshman and a senior. So these are mutually exclusive. All right, you could definitely be a freshman and not a senior at the same time. All right. Now, new scenario. Roswell has 2,230 students. There are 1,133 boys, 502 freshmen, and 241 freshman boys. Okay, Allie sees this question. How many Roswell students are boys or freshmen? She just adds up the number of boys and the number of freshmen and gets this number. But this is incorrect. Okay, what is wrong with Allie's reasoning? All right, the problem is that there is an overlap between these two sets. Okay, so we've got this many boys. All right. So if this is set B, this is boys. All right. So we have some boys, and then we've got the set of freshmen. All right. But there are some boys who are also freshmen. Specifically, there are 241 freshman boys. Okay. And in fact, I guess this is what is supposed to go down here. So there are 241 freshman boys. So here we have boys, and here we have freshmen. So the mistake that she made was she went ahead and added 1,133. Okay, plus, let me erase this for a second, plus the 502. All right, but the problem is she is counting the 241 students who are both boys and freshmen. She's counting them twice. Okay, so what she should have done was she should have subtracted that overlapping number from each group. So let's see, what is 1,133? 1,133 minus 241. That's 892. And she should have subtracted that from 502 as well. So 502 minus 241. That's 261. Okay. If she added these three numbers, that would give you the actual total number of students who are boys or freshmen. But just by adding this number, the 1,133, that includes the 241 overlap. And then she added the 502, but that also again includes the 241. So the 241 is being counted twice if you just add these two numbers together. Okay, so I'm just going to write that up in a sentence over here. Okay, so Allie is ignoring the overlap, which she is counting twice. That's what she's doing wrong. So we will just go ahead and add 892 plus 241 plus 261. So that should be the correct answer. Notice, this would be a good time for me to mention another way I could have done this without the Venn diagram would be, I mentioned in the notes earlier that there's an OR formula. A or B is going to be A plus B minus the overlap. Okay, so we could have done that. So we could have said, all right, if we wanted to find how many students are boys or freshmen. So boys or freshmen should equal boys plus freshmen minus the overlap. So we know that there are 1,133 boys. All right, plus 502 freshmen. Okay, minus the overlap of 241. All right, so we could have done it using the formula as well. All right, moving on. Among the Georgians who voted in the 2012 and 2016 presidential elections, this Venn diagram shows the percentage who voted for Obama in 2012 and the percentage who voted for Trump in 2016. All right, what number should go in the spot marked question mark above? Well, this would be the leftover percentage, and the total percentage is always going to be 100%. So we just need to subtract these numbers from 100%. So if we start with 100 and we subtract 24, 8, and 49, all right, that's 19%. Okay, so this little guy out here should be 19%. Okay, explain in words what this number tells us. All right, these would be the voters who neither voted for Obama in 2012 nor voted for Trump in 2016. So a common mistake is to say that, oh, these are people who didn't vote. We're talking about two different elections, and the question itself says that we're talking about voters, people who voted in both elections. So these people voted for other people besides Obama and Trump. So maybe in 2012, they voted for John McCain, and maybe in 2016 they ended up voting for Hillary Clinton. All right, so these are voters who voted for neither Obama nor Trump. Okay, so among Georgia voters, what percent voted for Obama in 2012? Let's see. So these are the voters that voted for Obama in 2012. All right, so that's going to be 32%. All right, what percent voted for Trump in 2016? All right, well, Trump 2016, we're talking about these voters right here. So that's going to be 57. Okay, voted for Obama and Trump. Well, that's this number right here. Okay, Obama or Trump. Okay? So Obama or Trump would be like this. All right? It's just all of both, right? All right, so that makes 81. All right. All right, so what is the percentage of people who voted for Obama and not Trump? All right, because that's what this means. Obama and not Trump. Okay, so Obama and not Trump would be just this number right here, outside of the Trump circle. Okay. Now, I know some of my students are going to see this P and feel like this needs to be a fraction, but that would just be 24 out of 100 if you really wanted to make it a fraction. So this next one means not Obama or Trump. All right, remember, or is more. Okay, so when you do an or problem, you just continually add on. So first, okay, so this is what we're doing. We're doing not Obama or Trump, okay? So not Obama would be this number and this number and this number. All right, these are all of the, okay, wait, I messed that up. Sorry, not Obama would be 49 and 19. Those numbers are not Obama. Okay, now, or Trump will include the 8%. So add these three numbers together, and that will give you not Obama or Trump. All right, or is more, so you add on the extra. All right, so that's 76%. Or 76 over 100 if you just want to make it a fraction. All right, what is the probability that one of these Georgians voted for Trump in 2016, given that he or she voted for Obama in 2012? Okay, so Trump given Obama. So the notation would look like this, by the way. What's the probability of voting for Trump given that you voted for Obama? Okay, now, in its basic form, probability is always target over total. And I like these given problems because it's always set up for you in this order. We have the target and we have the total. So what you want to do is start with the given. We're given that he or she voted for Obama. So this is what we are given. All right, so when you have a given problem, you start with a given and you throw out everything else. All right, so we're given that he or she voted for Obama. Okay, so we're dealing with this is the given. All right, so we have to throw out everything else. So throw out this number and this number. Okay, just stick with the given. Now, given this, now we're being asked, what's the probability that a person voted for Trump in 2016? Okay, what's the probability of Trump? So, target over total. Let's start with the new total, which is going to go right here. All right, now that we've crossed out some numbers, the new total is going to be the sum of these two. So that's going to be 32. Okay, now the target, this is the target. All right, and look, another way to look at it is the target is Trump and the total is Obama. All right, target over total, it's right there. So the out of the two numbers that I have, the Trump number is 8 because this is part of the Trump circle. So here's a new scenario. 70 students were asked about sports they like to play. According to this Venn diagram, some of the students play basketball, some of them play tennis, and some of them play football. Now, how many students surveyed play basketball? Well, these are the students that play basketball right here. So it's just a matter of adding up these four numbers, and that turns out to be 31. How many students play neither basketball nor football? Okay, so here is basketball or football, or these numbers. So the students who play neither basketball nor football are these students out here. So that's going to be 27 students. What is the probability? All right, as soon as I see the word probability, this is going to be a fraction. All right, notice how the other two problems I just did, it said how many, so I just wrote a whole number. Watch out. Anyway, what is the probability that a student plays none of these sports? Well, I'm looking at you, number 19. There are 19 students that play none of these sports. And so the probability is going to be target over total. So that's going to be 19 over whatever the total is. And the total was 70. 70 students were surveyed. So 19 out of 70. Now, we're moving on to another page, but it's the exact same scenario. What is the size of F and T? Now, it's time for me to add a little bit to the notes that we started. In addition to everything we already have written down, I want to add one more concept. And is less or is more. All right, you can kind of tell, glancing at my Venn diagrams, you can see that and is just the overlap, whereas or is going to be all of both. So it makes sense that and would be less and or would be more. But I'm going to use that in another way right now. If I want to do F and T, okay, so I'm keeping in mind that this is going to be less. So what I do is I will start with F, and F is going to be this number, this number, this number, and this number. All right, that's F, all of those four numbers. Now, I'm going to erase some of these, making it less, because now I need to consider that it has to be and t. All right, so considering that I only want the ones that are also t, can you see that I need to erase the 6 and the 11? The 2 and the 1 are also inside of t. All right, they also play tennis. So these have to go. So that's me making it less, and that's what I mean by and is less. Okay, so these are the numbers I'm going to use. 3. So that's just plain the answer. It says the size, not the probability, so I'm just going to put 3. All right, now let me erase to get ready for the next question. Okay, this is the notation for given. So this means, in words, the probability of t given f. Okay, focus on the given first. All right, anytime you have a given problem, start with the given and throw away everything else. So given f, so that means we're going to start with the given, and we're going to throw away everything else. Okay, so that means I need to cross out all of the other numbers. All right, so this is what we have. Now remember, probability is always target over total. Target over total. All right, now the target is going to be t. The total is going to be f. In other words, this notation almost looks like a fraction. Do you see how this t given f almost looks like t over f? It almost looks like that. So that's really helpful because this number in the front is going to wind up being the target. And this second number is going to wind up being the total. All right, so f is the new total. So how many students play football? That is 12 plus 8, so that's 20. So that's the new total. So the total is going to be 20. Now the target is going to be the number of students that play tennis. All right? Target over total, tennis over football. So tennis. All right, now out of these numbers that we didn't cross out, how many of these are tennis players? Well, that's going to be these two. All right, in other words, 3. 3 students play tennis out of the total number of students who play football. So that's 3 out of 20. All right, that's how you do a given problem. Are the events T and F mutually exclusive? Remember, mutually exclusive means that the two sets are not overlapping. They have nothing in common. But as you can see, the events T and F, set T and set F, do overlap right here. There are 3 students who play football and tennis. So they are overlapping. They are not mutually exclusive. So we will say no, they are not mutually exclusive. So there's my little explanation right there. There are some students, 3 to be exact, who play both tennis and football. So that's how I know that they are not mutually exclusive. Okay, moving on. All right, new scenario. We have this Venn diagram. All right, there's no context. We don't know what set A and set B are, but we'll just answer the questions anyway. Right, so this is the probability of A or B. All right, we know that A or B is all of both. So A or B is all of that. So that's 30 plus 10 is 40, plus 12 is 52. Be careful though, this is a probability, so we have to do target over total. All right, that P tells me that it's going to be a fraction. So I'm going to do 52 out of, and the total would include the 8 in addition to this, so that would be 60. Okay, now this is the probability of A and B. So that's going to involve the overlap. So we know that A and B is the overlap. So we're just talking about this part, which is 12. Again, this is probability, so I know it's going to be a fraction, so I'm going to do 12 out of 60. All right, this is that given business again. So this is read given. So when I do my probability, I'm going to do target over total. Okay, and the B is going to be the target. The A is going to be the total. All right, so the key is to start with the total. All right, start with the given and throw away everything else. So A is the given. All right, so A is going to be these two. All right, so that's the given. And now we have to throw away everything else. So we have to throw away the 10 and the 8. Now we do target over total. The new total is 42. Okay, so target over total, the new total is 42. The target is B. So that's what's going to go in the numerator is B. And out of the numbers we have left, the B number is 12. All right, because 12 is in the B circle. So that's going to be 12 out of 42. Okay, new scenario. 80 students were surveyed about the streaming services they have at home. Here are the results. Boom, boom, boom. All right, Netflix, Hulu, Netflix and Hulu. Let's complete the Venn diagram. The key to completing the Venn diagram is start with the middle section and then subtract for the outer sections. So the middle section, of course, is going to be this. These are the students that have both Netflix and Hulu. So the 14 goes right here. Okay, there are 80 students. Oh, well, no, it's not time for that yet. So 42 students have Netflix. All right, so that's why I'm going to do 42 minus 14 right now. Okay. So that's 28. So that tells me that I will put 28 right here in this outer part of the Netflix circle. Notice that 28 and 14 together make the 42 Netflix. All right, these two have to add up to 42. That's why I subtracted. And now I'm going to do the same thing with Hulu. All right, 23 students have Hulu. That's why I'm going to do 23 minus 14. And that's going to be 9. So I'll put 9 out here. Again, notice that these two numbers add up to 23, as they should. We also need to know what number belongs floating around out here. Students that have neither Netflix nor Hulu. Well, 80 students were surveyed. So we can subtract all three of these numbers from 80, and that will give us how many are left over. So 28, 14, 9. So that's 29. Okay, so now all 80 students are accounted for. This is your Venn diagram. All right, okay, I guess that was it. We're not going to use that for anything. So moving on. Event F has 5 letters. Event V starts with a vowel. A, E, I, O, U. Now, which of the following words belong in the set? And so this means F and not V. Okay, so let me just write that out as a reminder. F and not V. Hold on. Okay, so remember that and is less. I'm going to use that concept right now because this is an and problem. So I'm going to start with F. All right, F means 5 letters. So let's see, apple, that's 5 letters. All right, that's not 5 letters. That's not 5 letters. This is 5 letters. Okay, now and is less. So I'm definitely not going to include anything else. I'm going to go less, not more. Okay, so I've already narrowed it down to only 2 possibilities. Now, I might erase one of these because we're looking for ones that are not V. The V means starts with a vowel. Okay, so this one is not V because it doesn't start with a vowel. So that one's good, all right? So this one is F because it has 5 letters and not V because it doesn't start with a vowel. I have to throw this one out because it starts with a vowel. We want not V. Okay, so that one had to go. So this is the only one that is in the set F and not V. 5 letters and no vowel. Okay, so that's it. That's the answer right there. Technically they said circle, so let me go back and put a circle around it. Okay. Of course, this means F or V. All right, this should be simpler. Remember that or is more. So I'm going to use that concept right now. So I'm going to start with F, all right, which is the same as we discussed before. This has 5 letters, and this has 5 letters. So we've got 2 so far. But or is more. So I'm going to add on more based on this. Anything that has a vowel in front I'm going to add that on. So this has a vowel in front, so that will also be included. And that's it. So these are the answers. All right, so notice that in both cases we started with F. That was apple and lunch. But and is less, so I had to subtract away one of them. But or is more, so I wound up adding on an extra one. And that's it. That's the end of this quiz.